The limit definition of the derivative is the foundation for a large part of calculus. So we have a curve f of x, and on that curve we want to pick 2 points with which to calculate a slope for the curve. Now because our points are separate from each other, they're separated by a horizontal distance h, we're going to be finding what's called an average slope of the curve. And doing that requires that we have a rise and a run for our triangle here. So an average slope would be given by this formula, f of x plus h minus f of x over h. It's rise over run. And what we're going to do is we're going to approximate the derivative, which is the slope of the function, using this difference quotient. Okay, let's see how it works with a problem here down below. I want to approximate the derivative of x squared at the location x equals 1 using a width of my triangle being h equals 2. First thing I'm going to do is I'm going to just sketch the x squared curve. Okay, so x squared looks like this. Great. And I'll try to sketch a little function curve here. Okay, great. The points that we want to focus on first are definitely here at x equals 1. And we want to have an h of 2, which means we want to create a triangle whose width is 2 and whose rise is the difference between these 2 points. All right, so let's calculate the slope now of the secant line created when we connect one point to the other. All right, so use h equals 2. The formula says that the derivative of the function is approximated by f of x plus h minus f of x over h. We want to use h equals 2 and x equals 1. So we'll be finding f prime of 1, but it's only an estimate now. F prime of 1 plus 2 minus f of 1 is what we need. And then we'll divide that by the h of 2. So f of 1 plus 2 could be written as f of 3. And so it should be clear now that we want this height, f of 3, and we want to subtract f of 1 here to get the rise. So that's going to be 9 minus 1 over 2, which would be 4. So the slope of that thing is 4. And now what I want to do is I want to shrink my h down even smaller. I want to shrink it down to this triangle here. So my points come together. And I want to find a slope which looks like it will be a lower slope. Let's try that calculation. So use h equals 1 and x equals 1. So f prime of 1 can be approximated by f of 1 plus 1 minus f of 1 over 1. That's f of 2 minus f of 1. And this right here is f of 2. That's going to be 4 minus 1 over 1, which is 3. So yeah, our slope did go down. Now if h were to get infinitely close to 0, then we will actually find the derivative. And we'll find the true slope of the curve at x equals 1.